So now we're going to take a look at inclines that include different dynamics, like kind of what we see here is this piano is being lifted into the back of a truck. So if we consider all the forces here, we get the force of gravity. This guy's pulling this way, so force applied this way, force applied from these guys, and what they're fighting is some friction, this way. And so if we consider, I always have the normal force coming up at, perpendicular to the ramp. So if we consider all these, we can look at a dynamic situation like this and figure out what's going on. So some things that we're going to want to add to our incline sheet is it's important to draw a larger picture because a lot of times there's more than one force going on in the x direction, and so it's important to look at all of those. We'll draw our coordinate in the coordinate axis in the x and y, and sometimes it's more beneficial to set the x and y and positives and negatives reverse of what we're used to, so we'll see that. And also be careful when working with the sum of the forces in the y and x, especially now there's going to be more forces involved. Okay, so let's say that we have a block that's sitting on an incline, and we have an incline, the angle is 40 degrees, and we have the coefficient of kinetic friction, we've got the mass, and we want to find out what is the acceleration of this incline down the ramp. And so, we know here the angle is 40 degrees, and if we break up our x and y axis, so we want to draw our x and y axis, positive x here, negative x here, positive y, negative y. I want to be careful, negative y, positive y, with our components for the force of gravity. So we've got force of gravity this way, force of gravity this way, and our right angle is here. This is the hypotenuse, mg. And so go ahead and pause the clip. Go ahead and write out the sum of the forces in the x and y and in variable form, and then we'll take it from there. So go ahead and pause and then hit play when you're ready. Okay, so we have the force of gravity in x, force of gravity in y listed. Sum of the forces in the x, sum of the forces in the y. We should have for the y the normal force upwards, force of gravity in y downwards, and the acceleration is 0 in the y, just moving along the x-axis, right? And then for the x-axis, we have the positive force of gravity in the x and the negative force of friction here. And that's the new one here. We have the force of friction acting backwards, and we want to determine what the acceleration is. So if you remember, to find friction, right, that's the coefficient of kinetic friction times the normal force. So here is where we're going to need what the normal force is to be able to figure out what's going on with friction. And so what you're first going to want to do is go ahead and figure out what the normal force is. Once you do that, you're going to place that into here and calculate what the friction is, and use trig, to figure out what this is and the force of gravity in the x is. And go ahead and determine the acceleration. So go ahead and pause the clip and work through that, and then when you're ready, you can continue. Okay, so for the normal force, you should have gotten 262.75. And we place that in for the normal force, multiplying that by our coefficient, 0.012, and we should get for our acceleration 6.209 meters per second squared. Okay, so now what we're going to do is take a look at a situation where, kind of like what we saw in the first picture, where we're pulling something up a ramp and we have friction, and we know that friction always opposes the motion, and so we have the force applied going this way, but counteracting that would be friction going this way. We still have the force of gravity to the center of the earth, normal force perpendicular to the surface, but in this case, because we are pulling it up the ramp like this, it's going to be more beneficial to call this the positive x and this the negative x. And then as we set up the free body diagram with the coordinate axis, you know, and force of gravity in the y, force of gravity in the x. And if you notice, what direction is the force of gravity in the x? It's actually acting in the negative x, right? And then friction is action in the negative x, and then you have the force applied going upwards. So here's our variables. We have the mass of it, we have the acceleration going upwards, the coefficient of kinetic friction. So the question is, how much force is required here, force applied to pull it up the ramp at this rate? And so you're going to set up the sum of the forces and determine what force applied needs to be. So what we'll do is, why don't you go ahead and write out the sum of the forces and the x and y, and then pause the clip and make sure you've got the sum of the forces correct before you move on. So go ahead and pause, and then when you're ready, you can continue. Okay, so you should have gotten positive normal force plus the negative force of gravity in the y, so it's pretty similar there. And then in the x, the negative force of gravity in the x, right? It's acting in the negative here. Force of friction also in the negative, and then force applied is the only positive force, and that's going to help us. So go ahead and pause the clip again and determine what the normal force, what the force applied needs to be. When you're ready, you can hit play to continue. Okay, so mg sine 35 is the side of the FGX, and then we have the coefficient times the normal force, which we're going to have to get from here using the trig. So we should get 1,164.02 newtons for the normal force, and we place this into here, multiplied by the coefficient of kinetic friction, and we know the acceleration here, we know the mass. We should get 1,038.87 newtons as the force applied required to overcome friction and the force of gravity in the x, because we're fighting both of those as we pull it up the ramp. So now the rope breaks. So we're pulling it up the ramp, but the rope breaks. So what's going to change here? If you think about it, the incline now, the motion is going to be like this. It's actually going to fall down this way. And we know that friction always opposes the motion. And so friction is actually acting up the ramp now as it falls down. So we can use the same conventions here. We can use this as the negative x, use this as the positive x, and set up the sum of the forces. And let's go ahead and determine what the acceleration in the x will be. You're going to have to, you could use some of the same values there in terms of calculations, but go ahead and see if you can set up the sum of the forces and set up the equations, and calculate through and see if you can get the acceleration as it goes down the ramp. Okay, so alright, so let's see how you did. Then the force of gravity in the y, we have the normal force and force of gravity, and so we've got the same situation there with the normal force. Now in the x, this is different. We have the force of gravity in the x, acting in the negative, and then friction is actually going up the ramp, the positive. And so when we solve for the acceleration, it would be negative 4.577 meters per second squared as it accelerates down the ramp. So this is an important problem because we can evaluate what's going on, with friction opposing the motion, and so we just have to be cognizant of that as you work through these.